Welcome to the video for tutorial 7. We will firstly be looking at the exercises under section 2.6. The first two that we're looking at asks us to find dy dx by implicit differentiation. So we are using implicit differentiation in this case because we are not able to write y on its own as the subject of the equation. So we are going to start with our first term. We have x squared y squared. So we are going to treat this as a product because it's the product of x squared and y squared. So we are going to apply the product rule. So it's going to be the first times the derivative of the second, which will be 2y. But we are not done. We still have to multiply with dy dx because we are taking the derivative with respect to x. Then we have plus the derivative of the first, which is going to be 2x, and then we have multiplied by the second, y squared. We are now looking at our second term, which is once again a product of x and sin y. So we are going to take the first multiplied by the derivative of the second, so that's cos y. We are not done. It's still dy dx. We have to write there. And then we have plus the derivative of the first, which is just 1, multiplied by the second, so it's sin y. And then we have the derivative of 4, which is a constant, so the derivative of the constant is just 0. Our next step is we want to make dy dx the subject of the equation. So I'm going to say dy dx, then I'm going to take out 2x squared y plus x cos y equals, and then I take the other two terms to the other side of the equal sign, minus sin y minus 2x squared y squared. So dy dx is then equal to minus sin y minus 2x squared y squared over 2x squared y plus x cos y. There's just a tiny mistake here. Sorry about that. So this is not supposed to be an x squared. That's just supposed to be an x. And also, this is not supposed to be an x squared. That's just an x. Next, we are looking at number 17. We have the square root of x times y equals 1 plus x squared y. Once again, we are going to apply implicit differentiation. I'm just going to write this as xy to the power half. So I'm going to take the derivative of that. That gives us a half xy to the power minus a half. And then I have the inside function, which is x times y, so that's a product. So I'm going to take the derivative of that product. So it's going to be the first times the derivative of the second, plus the derivative of the first, which is 1 times the second, equals, on the right-hand side, I have the derivative of 1, which is 0, and then I once again have a product. So it's going to be the first times the derivative of the second, plus the derivative of the first times the second. Once again, I now want to make dy dx the subject of the equation. I'm not going to show all of the steps, but your final answer when you have done that will be 4xy times the square root of xy minus y over x minus 2x squared times the square root of xy, or an equivalent form of that. We are now looking at number 21. It says if f of x plus x squared times f of x cubed equals 10 and f at 1 equals 2, find the derivative of f at 1. So we are going to take this equation, we are going to use implicit differentiation in order to be able to find f's derivative, and we use implicit differentiation once again because it's not possible for us to isolate f's f on the left hand side and then determine the derivative. So I'm going to say I have the derivative of f, then I have a product. So I'm going to apply the product rule to take the derivative of that. It's going to be the first multiplied by the derivative of the second. So it's 3 times f of x squared, and then still multiplied by the derivative of the inside. And then I have plus the derivative of the first, so that's 2x multiplied by the second. And then on the right, I have the derivative of 10, which is 0. I want to make the derivative of f my subject. So I'm going to say I have the derivative of f. And then I take out the derivative of f as a common factor from the terms containing the derivative of f. Then I get 1 plus 3x squared f of x squared equals minus 2x f of x cubed. So that means f's derivative of x is going to be minus 2x f of x cubed over 1 plus 3x squared f of x squared. So we were asked to find the derivative when x equals 1, and we are given that when x equals 1, we have f of 1 equals 2. So what we are going to do now is we are just simply going to substitute into this equation the values when x equals 1 and f of 1 is going to be 2. So I'm going to have f's derivative at 1 is going to be minus 2 multiplied by 1. Then I have f of 1 cubed, and f of 1 we said is 2. Then I have 1 plus 3 multiplied by 1 squared, and then I have f of 1 squared, f of 1 is 2. So I end up having minus 2 multiplied by 8 over 1 plus 3 multiplied by 4, which gives us minus 16 over 13. The next one we're looking at is number 27, and it says use implicit differentiation to find an equation of the tangent line at the given point. Okay, so what we want to do here is we want to find firstly the gradient of the tangent line at that point, and then we want to substitute the gradient of that line and also a point into an equation for a straight line so that we can find the equation for the tangent line at that point. So the first thing we're going to do is we want to find the gradient of the line by taking the derivative. So we are going to use implicit differentiation because we can't isolate y in this equation once again. So let's use implicit differentiation. So it's going to be 2x. Then we have a product. So that's going to be minus the first times the derivative of the second. So I'm just writing y prime instead of dy dx. And then I have plus the derivative of the first, which is just 1, multiplied by y, the second. And then I have minus 2y multiplied by the derivative of y, which is just y prime. And then it equals the derivative of 1, which is 0. So I'm going to write all of my terms containing y prime together. And then I'm going to take my other terms to the other side so that I can make y prime the subject. So I'm going to have 2x minus y prime, x plus 2y minus y equals 0. So y prime is going to equal y minus 2x over minus x plus 2y. And that I can just rewrite by multiplying by minus 1 over minus 1 as 2x minus y over x plus 2y. I was asked to find the equation of the tangent line at the point 2, 1. So I'm just firstly going to find my gradient at the point 2, 1 by substituting 2 and 1 into this equation. So y prime is then 2 multiplied by 2 minus 1 over 2 plus 2 multiplied by 1, which gives us 3 over 4. And to find the equation, we are going to use the gradient and a point on the line. So I'm going to say I'm going to use y minus y1 equals the gradient times x minus x1. I have the point 2, 1. So I'm going to substitute that in there. So I get y minus 1 equals 3 over 4 x minus 2. And then I can just make y the subject. And I eventually get y equals 3 over 4x minus a half. So the next problem we're looking at is number 39. It says, if xy plus y cubed equals 1, find the value of y double prime at the point where x equals 0. So I'm going to have to apply implicit differentiation twice in order to get an equation containing y double prime. So let's just do that first. So we take our first equation, I'm just going to call that number 1. Then I'm going to apply implicit differentiation. I'm going to apply implicit differentiation to get the first derivative. So I'm going to have, I have a product. This is a product. So it's going to be the first times the derivative of the second plus the derivative of the first times the second. Then I have plus the derivative of y cubed, which is 3y squared multiplied by y prime equals the derivative of 1, which is 0. Now I want to apply implicit differentiation once again. So I have a product. I'm going to apply it to that product. So it's the first times the derivative of the second plus the derivative of the first, which is 1, times the second, which is going to be y prime. So that's my first product. Then I have the derivative of just y, which is y prime. And then I have another product. I'm just going to write 3 in front there. And then it's going to be the first times the derivative of the second plus the derivative of the first, which will be 2y. I'm not done. Multiplied by y prime. And then multiplied by that y prime. Equals 0. So, what did they ask? They asked us, we want y prime, y double prime, where x equals 0. So what we're going to do is, we are going to find y when x equals 0. We are going to find y prime when x equals 0. Then we're going to substitute this, and x equals 0 into equation number 3. So what we're going to do is we're going to take equation number 1, when x equals 0, and then it becomes y cubed equals 1, so y equals 1. Then we're going to take equation number 2, when x equals 0, and y equals 1, which gives us 1 plus 3y prime equals 0. So we get y prime equals minus a third. And then finally, we are going to say when x equals 0, y equals 1, and y prime equals minus a third, I'm going to have 0 minus a third plus 3 times y double prime plus 2 minus a third squared equals 0. And then I'm going to solve for y double prime. So what I have here is I have 3, and then I have y double prime plus 2 over 9 equals 2 over 3. So y double prime plus 2 over 9 equals 2 over 9. So y double prime will be 0. And that's what we wanted to solve. We are now looking at the exercises under section 6.3. And the next two asks us to solve for x. So we have number 32, and it is 10 times 1 plus e to the minus x all to the minus 1 equals 3. So I just want to solve for x. So what I'm going to do is I'm going to say this means that 1 over 1 plus e to the minus x equals 3 over 10, which means that 1 plus e to the minus x equals 10 over 3, which means that e to the minus x will equal 10 minus 3 over 3, which is 7 over 3. And I want to solve for x. So what I'm going to use is the fact that if I take ln of e to some power, that just equals that power. So I'm going to take ln on both sides of the equation. I'm going to say ln of e to the minus x equals ln of 7 over 3. Then on the left-hand side, it simply becomes minus x. And on the right-hand side, I still have ln of 7 over 3. That becomes x equals minus ln of 7 over 3. And then I can take this minus and I can write it as an exponent. So I have x equals ln of 7 over 3 to the minus 1, which is then ln of 3 over 7. Next, we have number 33, and it says ln of x equals 1. So what I'm going to use here is the fact that e to the ln of a simply equals a. So I'm going to write both sides as e to the power of what we currently have. So it's going to be e to the ln x equals e to the 1. Now on my left-hand side, I have e to the ln of ln x. And if I compare it to this equation I have here, that's just going to be equal to ln x. And on the right-hand side, I have e to the 1. Now, I'm going to repeat what I did by saying I'm going to take e to the ln x equals e to the e. And now this is going to be equal to x on the left-hand side, and on the right-hand side, we have e to the e. And that's what we wanted to solve. The next one we're looking at is number 63. It says find the inverse function of y equals 3 to the 2x minus 4. So I'm just going to say, let's say f is the function we are given. So f's inverse, to get f's inverse, we are simply going to swap the positions of x and y. So x equals 3 to the 2y minus 4. And we want to make y our subject. So I'm going to say, I know that log base 3 of x equals 2y minus 4. And then I'm just going to say, so therefore we have 2y equals log of base 3x plus 4. So y equals a half log base 3x plus 2. This is the end of this week's video.